We now determine the intervals of decrease. We can determine that by preparing sign chart for the first derivative of the function, that is for g prime of x. So I'm going to prepare the sign chart. Since we already know that negative 6 and 0 are the critical points of the function, so we put this one of the critical point 0, and the other one is negative 6. This one is basically the sign chart for g prime of x, and also it is determined that the intervals of increase is negative 6 to 0. So in this interval negative 6 0, the function is increasing. So this one is an increasing interval, and also in the interval 0 to infinity, the function is increasing. So we have only one interval left, that is we have to check if in this interval, that is from 0, sorry, this is from negative infinity to negative 6, if the function is decreasing. We can do so by plugging in some random values into the first derivative in this interval. So let's consider the random value. Let's say x equals negative 10. We plug this into the g prime of x equation. So I'm going to use the factor form of g prime of x. This equals 4x squared times x plus 6. And so when we plug in x equal to negative 10 into this g prime of x, we get the first term is going to be anyway positive. This is 4 times of negative 10 squared times negative 10 plus 6. This is going to be positive always because it's a square term. And this one gives negative 4. So positive terms times negative number is a negative number. So ultimately we get a negative value. And this means the first derivative is negative. According to the first derivative test, whenever the first derivative is negative, we see that the function is decreasing in that interval. So therefore, we can now confirm that the decreasing interval is negative. This one is negative infinity, negative 6. So we write the decreasing interval of the function g of x is negative infinity, negative 6.